Welcome back, guys. Thank you for watching this video. In this video we are going to look at example concerning how to calculate variance and standard deviation for ungrouped data. So first and foremost, the example we have is reading that find the variance and standard deviation for the following data. We have 5, we have 8, we have 13, and 12, and 15. Those are the data which they have given us, or the number of variables which we have. But as we said earlier, that before you tackle any question, it's better to organize your work or your variables or your data in a table to make it more easier to follow and then to make more meaning. So as we said, the first column should always take the variable. So in this case, our variable, we shall call it variable x, and then values under variable x, we have the data which is given. We have 5, we have 8, we have 12, we have 13, we have 15. So we said when we are calculating mean and variance, you must, when you are calculating variance and standard deviation, you must have summation of x squared and the summation of x. So whenever you finish putting the variable x, is better immediately you come down and get the summation of that data. So here we shall look at summation of x. So summation of x, we shall add each and everything in the column of x, and then we get its total downward. So we shall have 5 plus 8, which we are going to get 13. Then 13 plus 12, that is 25. Then 25 plus 13, we get 38. Then 38 plus 15, we get 53. If you are not sure, make sure you use calculator such that you avoid getting wrong things. And once you get wrong summation, implying that all your working will become wrong. No one is going to mark your working when you have wrong summations, because whatever you are doing there to acquire you to use what you got here, and if you got wrong things, then whatever you be doing there will also be wrong. Then we lead to loss of marks. So it's better to use calculator, even though you are trusting your head, but to verify using calculator. Then the next column, it will be for x squared. X squared means whatever variable we have here, we shall square it to get our value of x squared. So like here, we shall have 5 squared, we shall get 25. 8 squared, we shall get 64. Then 12 squared, we shall get 144. Then 13 squared, we shall get 169. Then 15 squared, we shall get 225. So these are our values of x squared. Immediately, as we did to the value of x, we shall also do the same. That is summing the all values under x squared, or in the column of x squared. So we shall get the values of x squared. So the values of x squared, we shall add 25 plus 64 plus 144 plus 169 plus 225. So we are getting 627. So 627, this now we have computed our table. We go to the first part, which is saying variance of x. We said we denote it as var x, which equals to summation of x squared out of n minus summation of x out of n to square. We square summation of x out of n. So here we have summation of x squared, we have summation of x. What is missing is we are missing n. N, we just count the numbers of variables. So we have 1, 2, 3, 4, 5. So implying our n equals to 5. Those are numbers of variables. That one implies that we have 5 variables in our data sets which they have given us. So after immediately we shall substitute for values of summation of x squared and the summation of x respectively. So our var x become summation of x squared. Now we substitute in with 627 divided by n. You said n is our 5. We got it as 5. Minus the square of summation of x, which is 53, divided by summation of, divided by n, which is 5, and which is in squared. So we shall divide and square immediately. We shall have 627 divided by 5. We are getting 125.4. Then minus 53 divided by 5. We are getting 10.6. But this 10.6 we are squaring it. So here we shall have variance as 125.4 minus 10 squared. We are getting 112.36. So we shall have 125.4 minus 112.36. So our answer become 13.04. This is our var x, and then var x. So that's the first part of calculating variance, and then they are saying we also calculate standard deviation. But we said standard deviation which we denoted as SD is given by SD equals to square root of var x. But our var x is given as 13.04. So square root of 13.04 will give us standard deviation, which is equals to 3.61 when we correct to 2 BPs. So that one become the values of our variance and the standard deviations. Thank you for watching.